Started. Okay, so this is the a video for using the trigonometric identities that are on the formula sheet, which is posted in I think weeks 4 or 5. But I just wanted to start off with reminding you of some things that you've already done. This is an assignment from previous week, evaluating trigonometric functions, when we did just the basic, air quote, basic unit circle stuff. And what we're doing now is basically you're going to do just a little new thing, and it's going to turn into this type of question. Or down at the bottom of the page, there were things that were not on the unit circle. They were the right triangle, Pythagorean theorem, SOHCAHTOA type questions. And the same thing is going to happen. You're going to have some new questions that will turn into this. You'll use both of these ideas and techniques in order to answer the new questions that you'll find. Let's see if I remember. So this is a sum and difference formula. We did the stuff with the basic identities before, and so now we're moving on to more complicated things. So the ones that give you the angle are going to be the ones that eventually turn into, back at this old assignment, things that look like this. Sine of 2 pi over 3, cosecant of 11 pi over 4, is that right? 7 pi over 4, I don't know. And then some of them, down here at the bottom, you are not given the angle measure, you're given that output number, like that. And so you can see cosine of an angle is this number, and that angle is in a specific quadrant. Go back to what you've done before, and that's identical to this down here. So you are using this previous knowledge that you gained in order to answer these new questions like that. So with that in mind, and what I'm going to cover in a couple of these videos are the sum and difference in different ways, and then these. So I just kind of just randomly pick some identities and go through things like that. And you can see, this type of question where you've got the number and not the angle, you could have any of those formulas. The sum difference, the double, the half, different combinations of things like that. Now, beyond this, that's not in the video, there's more verify, and then these matching assignments are similar to the simplify, and they could be verify because know one of these answers is correct, a match over there, like that. So my biggest advice is just become as familiar as you can with the identities on the formula sheet, which are at the back here somewhere. It used to be page 65. Looks like, there we go. So this sheet in the lab manual has a few things not given on the test. I will give you the formula sheet for the test, and you can find the actual one, like I said, in the week 5. So let's start with some examples. I'm going to come back to the formula sheet. So what I was saying was you just have to get familiar with the idea, pardon me, of the identity. So you'll notice there's they're grouped different ways, but the big group is there's two angles, sine of A plus B, and then down here, you'll also know that there's an A and a B. The other identities just have a single angle. So that's kind of how you narrow in on that. Sometimes there's more than one choice to use. Sometimes there's only one choice. There's a better choice. There's a not so good choice. Anyways, let's take a look at an example here. So determine exact value sine of 5 pi over 12. So the first thing that you do is determine the identity you want to use. Now, for any of the pi over 12 variations, you can use the sum or difference formulas, or you could use the half angle. And I'll show you a half angle example probably in a different video. We'll see what happens. So for the sum and difference, you're coming up with two unit circle values that will add or subtract and equal that original angle you're given, 5 pi over 12. And you can see my line a couple of lines below the solution here where I've got those two original unit circle angles. And you can see my math that I've done here. And the second and third step here, where I'm circling my cursor, that is the formula sheet. So sum and difference sine of angle 1 plus second angle splits apart on the right side like this. Oh, wrong click there. And that's where it goes back to that original unit circle stuff. Sine of pi over 4. What's that? Boom. Angle in the middle, number in the middle. Cosine, pi over 6. Well, if sine of pi over 6 is the small number, then cosine of pi over 6 is the big number, square root of 3 over 2, etc., etc. And then you do some arithmetic. So the formula sheet basically is just identifying it and then writing it correctly, and you're done with the formula sheet, pretty much. Immediately you go right back to the original special angles on the unit circle, and then you do a little arithmetic, and you're done like that. So what I've seen a lot of students do is they just don't practice enough, and they're not familiar with the identities on the formula sheet. And maybe they're just not familiar with where they are. I mean, I've had students that don't even answer the question on the test, and all I can think of is they just couldn't find the identity. I don't know why they don't answer it. And then other students use it incorrectly. So you've got to practice enough so that you know all of these different variations and how to use them and which is a better choice. And then you'll do fine. Anyway, okay, so another example, exact value cosine 7 pi over 12. So you can see my first line is how I broke that apart into two things. Now, one of the things I'd recommend is go back and do this one and find two different unit circle angles than what I have in my example and use them. And you should get the exact same answer. If you use the half angle, it'll be different. But if you go back and find alternative angles that add or subtract to equal the 5 pi over 12, or in this one on the bottom, the 7 pi over 12, that's going to be some good practice for you and help you out there. So we've broken the 7 pi over 12 into the two original unit circle angles, and then we go right to the formula sheet. So this is cosine of two things added. That's the second one right there. Can I highlight? There we go. I can highlight. And now you don't memorize these on the formula sheet. You can see they all look very similar, but they could be a little confusing. So just know where they are and how to use them. And then that second line, cosine pi over 3. Like I said, that just went straight back to the unit circle stuff that you did a couple of weeks ago. That's the big angle. You know, sine of the big angle gets the big number. So cosine will get the small number, etc., like that. All righty, let's see what we've got next here. Okay, this is a variation where we are starting on the right side of the equal sign on the formula sheet. So there's two different angles. So we know the formula sheet, that's going to be the A and B. And we've got cosine times cosine, and then sine times sine. That will kind of process of elimination of where those are. So they're plus. So this one at the top, cosine, cosine, different angles, plus sine, sine, different angles. Now there's one down at the bottom that has similar parts. So right here, the sum to product, let's highlight that, just the part after the two, A plus B is one angle, A minus B is a completely different angle, cosine times cosine. So there are similarities. And then down here, we've got that same thing, cosine angle 1 times cosine angle 2. So there's elements of the formula in a couple of different of identities, but there's always kind of a better one to use. So as you get more familiar with it, you'll know, a better choice, and it'll make it a simpler question to answer like that. Another one with tangent. This one, again, you've got to recognize both the formula on the left and the formula on the right of the equals. So tangent, two different angles with a plus. So the only tangents are up at the top. You'll notice in the sum to product, all these down at the bottom half, there are no tangents here. So that does kind of minimize it. The ones in the middle, we've got the half angle, that's only one angle. We've got the double angle, that's only one angle. So there's limited choices. So just being aware of these kind of broad distinctions can help you narrow down where to use that. So two different tangents on top with a plus, and that's this first one over here. Two different tangents on top with a plus. So look for that distinguishing characteristic, and that'll help you narrow down. So this formula says take those two angles, add them into a single tangent like that. So that's what I do over on the right. We do a little bit of common denominator in that next step. 3/18, pi over 6. Now you might have the tangents memorized. I don't, so I always go back. You need to know that quotient identity. So sine on top, that's the small angle. So the 1/2 goes on top, and the square root of 3 goes on the bottom, and you can see how that simplifies right there. The little denominators are both the same, so they just cancel each other out like that. So again, just to remind you, anytime you're given the angle measure, this is always going to turn into some original unit circle thing after you manipulate it just a little bit. All right, let's scroll through these and see. Okay, this is another one. I'm trying to break up the videos. Wasn't sure how I did these. Anyway, so tangent 5 pi over 12. Find the two angles. Now I did 5 pi over 12 in the first example, and you can see I had pi over 4 and pi over 6 were my two angles. Now I've tried something different. And that's what I was suggesting. Any of these, just go and try, something different. You could, quadrant 1, 2, 3, 4. You could go backwards with negative angles. The more you practice that kind of independent stuff and not just do what's in front of you, that builds your skill and you get better at it. So 8 minus 3 is the 5. And that simplifies to 2 pi over 3 and pi over 4. So both of these have to be on the unit circle. You can't do 4 pi over 12 plus a single pi over 12. That's not going to work. And this is the tangent difference. So on the formula sheet, we split it up based on that formula right there. And again, here's my little thinking for my tangent stuff. And you can see tangent 2 pi over 3, we get this ratio over on the right here, and that simplifies to just the square root of 3. 2 pi over 3 is in quadrant 2, so the cosine in the denominator is negative, so the answer for tangent is negative as well. And you can see how I simplified it, and I'm not rationalizing. At no point have I ever said you have to rationalize, and you don't on WebAssign. The lab manual might go through a couple of things, so you've got to watch that. Okay, let's scroll through these. That's all the sum and difference. I'm going to break the video based on what I'm seeing on my other examples here and come back and do another video for the rest of it. Let me get where I need to be so I know where to start here. All right, so stop the video and do another one, because that looks like we've been here for a while.